All right, so our video on solving polynomials part 2 is instead of factoring to find all of our zeros of a polynomial, we are going to start by using one known factor, either provided for you by your teacher or found in your graphing calculator, to then use division to find the rest of the zeros. All right, so a little bit different process than what we were doing before, but all things that we have the ability to do. So first thing, warm up / review. It says use synthetic division. So synthetic division to show that x plus 2 is a factor. Remember that to be a factor means that we will have a remainder of 0. So if I'm using synthetic division, I'm going to put -2, the 0, in the box. And then across the top, I'm going to list my 1, 10, 31, and 30. I do not need a placeholder because I have all of my values that I need. So I bring down the 1. -2 times 1 is -2. 10 minus 2 is 8. -2 times 8 is -16. Adding those down, I get 15. -2 times 15 is -30, and I get a remainder of 0. Okay? So it says, I know that x plus 2 is a factor of m of x because my remainder was equal to 0. All right. Just to recall from our video about solving polynomials yesterday, to solve a polynomial means to find all solutions to the function. Real solutions, so no i's, will appear as x-intercepts. And remember, if you have an even multiplicity, then we're going to bounce. If you have an odd multiplicity, then we pass through. Sometimes we'll flatten out or level off a little bit too if that odd number is greater than 1. Irrational solutions will come in conjugate pairs, so we will always have the plus and minus in front of an irrational square root answer. So we worked on all of this yesterday. We should feel good about that. If not, you might want to go back and rewatch the video. Today we're going to focus on this guy, graphing on a calculator to find one root, apply division strategies until we get to a quadratic function, then use quadratic techniques. That's a lot of math jargon. So quadratic function would be something with x to the second power. Quadratic techniques would be factoring, complete the square, or everybody's favorite, the quadratic formula, because that will always work. So getting to a quadratic, something with x to the second power, will be helpful for us because we can solve quadratics in a variety of ways. All right, so in our warm-up, we saw that x plus 2 is a factor of this function. It says now find all zeros. So what I like to do is I like to list my zeros off to one side. I already know, because of my synthetic division, I'm going to do that again. Because of my synthetic division, I already know that -2 is going to be a 0. Because x plus 2 was a factor, which means I had a remainder of 0. So all I'm doing here is copying down what you guys already had in your warm-up. You might want to add that back. So I just found that one of my zeros is x equals -2. How many zeros am I supposed to have? I'm supposed to have 3. All right, well, when I factored this down, I now have 15 plus 8x plus 1x squared. Well, this is a quadratic. That's what I was supposed to be doing. So I'm looking to maybe factor this, or I could use the quadratic formula. But luckily for me, I'm factoring things that multiply to 15 and add to 8. That works. So now I've got this factored, and I'm going to get x equals -3 and x equals -5. So I have found all of my zeros. If I wanted to write this whole thing in factored form, it would look like this. What was my polynomial named? M of x is my polynomial name. So this is what we call factored form. This is finding all of the zeros. All right. Now I mentioned you could use the quadratic formula. So what I would do is if I wanted to use the quadratic formula, this becomes my A, my B, and my C. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. And in cleaning that up, I get x equals -8 plus or minus the square root. If you put this in your calculator, it's the square root of 4 all over 2. Well, that means -8 plus or minus 2 over 2. -8 plus 2 over 2 is going to be equal to -3. And -8 minus 2 over 2 is going to be equal to -5. Wow, exactly. All right, sometimes we aren't lucky enough to be given a factor. Like in our warm-up, I gave you a factor from our teacher to get started, and sometimes we have to do a little more investigative work when a function doesn't factor so nicely. Also, considering the quadratic formula. You might be asking, but how am I supposed to just magically know what to divide by? And to that I say, let's think about our calculator. So, in your calculator, it says find all zeros of the polynomial. Well, first of all, if I want to find all the zeros, remember I like to start a little list over to the side. I know that I'm going to have 3 zeros. So I'm going to go to my graphing calculator because my teacher didn't give me one that would already work. So I'm going to go to y equals, and I'm going to type in 2x to the third minus 13x squared plus 13x plus 28. Go ahead and pause your video and type that into your y equals button. Just this one, the y2. Okay, you're just typing in your function right there. All right, so hopefully your graph looks like this. And what we're going to do is we're going to try to find one nice zero. Well, it's kind of hard to tell where I'm crossing the x-axis perfectly. So I can go to second, where it says table in blue right there. So second graph, and I'm looking for an x value that gives me a 0. Well, it looks like 4 gives me a 0. So I'm going to put 4 in the synthetic box, and x equals 4 will be my 0 to get started. So 2, -13, 13, 28. Synthetic division. If you are stuck on your synthetic division, I strongly suggest that you go back to the videos and review. And I got a remainder of 0, just like I wanted. Notice what's left. I have -7, I have -5x, and I have 2x squared. So from here I got to a quadratic. I could factor by splitting the middle term, but that's a lot. I know that the quadratic formula will work. If it's not quick to factor, using the quadratic formula is totally fine. So here's a, b, and c. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Okay, so to clean that up, this will be 4 times 2, which is 8. 8 times 7 is 56. 25 and 56 is going to make 81. Think 56, 25, 11, carry the 1, 81. Okay, all over 4. Well, the square root of 81 is 9, so this will be 5 plus 9 over 4 and 5 minus 9 over 4. 5 plus 9 is 14 over 4 is the same thing as 7 over 2. And 5 minus 9 is negative 4 over 4, which is the same thing as negative 1. So I found all three of my zeros. If I look back at my calculator on my graph, it looks like I am crossing at 7/2, which is 3.5, and I'm crossing at negative 1. So everything checks out okay. All right, this one, you are going to start from the beginning and work to find all of the zeros. I strongly suggest you go to your y equals and type in, you can clear out everything, I just have a lot in here for the sake of the video. Where I have y4, you can go ahead and type in that function and then see if you can work to find all of the zeros. Okay, it's important that you take time to graph this for yourself because you got to know how to do this on your own. Pause your video, type in your function, and work to find all of the zeros. All right, so I came up with zeros of 5, negative 3, and negative 3. From my calculator, I went to second graph, which got me my table, and right away I saw I had a 0 when x is 5. So I chose to put that in my synthetic box. Now, you might have gone off the graph itself and said, well, I'm definitely bouncing at negative 3. So you could have put negative 3 in this synthetic box. Your answers are going to come out the same, even if your work was a little bit different. If you got these 3 answers doing work on your own without a neighbor, you are good to go. Okay? So I'll let you look at my work if you need it, but make sure you know how to do this process on your own. Pause if you need to. Now would be a good time to ask your teacher a question if you are stuck on what we just did here. All right, last one. Find all zeros of this polynomial, x to the 5th minus 19x to the 3rd plus 48x. I say challenge accepted. So to start, I'm going to notice that I have an x in all of these, so I'm going to factor this with a GCF to get started. And now when I go through and I find my zeros, I know that x equals 0 is going to be one of them. And I know from this, I am looking for 4 others. So start by graphing on your calculator. You can graph the whole function if you would like, with the x to the 5th still in it, that's fine. I actually, though, want to go ahead and graph when I have taken out the 0. So x to the 4th minus 19x squared plus 48x. So I'm going to choose that one, okay, because then I can only worry about the zeros on here to get started. If I go to my table, I have a 0 at 4, so that's where I'm going to get started. So I already took care of this x being equal to 0, which means that when I put this 4 in the synthetic box, I only have to worry about the part that's in green. So 1, 0, negative 19, another 0 as a placeholder, 48. Bring down the 1. 4 times 1 is 4. 16. If this is going too fast for you, you may go back and pause the video. But I get to this lovely 0. Now from here, I have a couple different options. I just learned that x equals 4 is a 0. I could rewrite this as x to the 3rd plus 4x squared minus 3x minus 12. And I could try factoring by grouping. Or I could start this whole process again and go back to my calculator and grab another 0. This one, I think you should factor by grouping and then solve from there. So pause for a second and factor by grouping. All right, so I factored by grouping, and then I set each one of my factors equal to 0. When I took the square root, I got plus or minus. Notice that my final collection of zeros, I have 1, 2, 3, 4, 5. Because I started with x to the 5th. If you had jumped back to your calculator, you could have found negative 4 as a 0 and done division again and got to a quadratic formula. But remember, you want to try to factor. If you can factor after the first division, that's best.